Welcome to The Explainer. So what if you could create a form of matter that, well, doesn't actually exist in nature, even if it's just for a blink or less than a blink of an eye? We're going to dive into exactly that, pulling from a really cool conversation with materials scientist Dr. Anthony Grubisic-Sabor on Under the Microscope, the flagship podcast from the Science Talk. Okay, so at the heart of all this is a truly mind-bending idea. Dr. Grubisic-Gabal's team, what they're doing is they're using these super intense laser pulses to blast materials and force them into completely new states of being. We're talking about creating something that is fundamentally new. But of course, there's a catch. As you can see from her quote, these new phases of matter are, well, they're gone in a flash. They only last for a femtosecond. And if you're wondering what that is, it's a quadrillionth of a second. I mean, to put that into perspective, you could blink your eye and you'd have missed it literally trillions of times over. It's just gone.
So, okay, this brings up a pretty obvious question, right? Why on earth would you go through all this effort to create something that disappears almost instantly? I mean, what can you possibly learn in a quadrillionth of a second?
Well, it turns out that tiny fleeting moment, it's like a little window into the future of our technology. See, this research could solve one of the biggest problems holding back all of our modern electronics: heat. All that wasted energy.
Yeah, think about it. Our electronics right now are kind of like leaky pipes. They waste a ton of energy just by getting hot. That's what drains your phone battery. It's what limits how fast your laptop can run. But these new topological materials, they're different. They're like perfect insulated superhighways for electricity. Almost no energy is lost as heat, and that could lead to ultra-fast devices that stay cool no matter what.
Okay, but to even study these incredible materials, you need perfect, pristine samples that are literally just one atom thick. And for years, that was a huge problem, a massive roadblock for the whole field. But Dr. Grubisic-Sabor's team came up with this really clever, surprisingly simple solution. They actually call it the KISS method, and it's brilliant. They work in this super clean vacuum, and they basically use a perfect crystal of gold as a kind of atomic-level sticky tape. They just gently kiss it to the material, and it peels off one single perfect atomic layer. It sounds almost too simple, right? But it's a total game changer for making these samples. And you know what's really cool? This whole breakthrough didn't just happen in some sterile lab. As Dr. Grubisic-Sabor puts it, it came from what she calls an international team of scientific besties. I love that. It's just a great reminder that science is all about people, about collaboration at the end of the day.
And that whole idea of global collaboration, that's really the story of Dr. Grubisic-Sabor's own career.
I mean, look at this journey. Her path took her all over the world, from her master's in Croatia to a PhD in Denmark, then postdoc work in Australia and Sweden, and now she's a professor in the Netherlands. It's that exact journey, that international experience, that let her build the team and the expertise to pull off something like this. So when you put it all together, you have a fleeting flash of light creating brand new physics and a clever kiss that lets us study it. It's all paving the way for a future with some seriously powerful new technology. It really makes you wonder, doesn't it? What amazing new physics will the next scientific kiss unlock for us?